50 years of NASA historic space program footage. A comprehensive history of the America's exploration of space, including the historic mission to the Moon by Apollo 11, the flight of John Glenn in Friendship 7, the docking of Apollo and Soyuz, the scientific breakthrough of Skylab, the Challenger disaster, and more.
Be described as relaxed. Apollo 13, man's fifth lunar mission. The third, scheduled to land on the Moon, continued its tranquil coast.
This is the crew of Apollo 13, wishing everybody there a nice evening, and we're just about to close out our inspection of Aquarius and get back for a pleasant evening at Odyssey. Good night.
13, we've got one more item for you when you get a chance. We'd like it to stir up your cryo tanks. In addition, I have Shaft and Trunnion
Okay.
for a look at the Comet Bennett if you need it.
Okay. Stand by. Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Yes, Houston, we've had a problem. We've had a main B bus undervolt.
Roger, main B undervolt. Okay, stand by, 13. We're looking at it.
And we had a pretty large bang associated with the caution and warning there. And as I recall, main B was the one that had a amp spike on it once before. In the interim here, we're starting to go ahead and button up the tunnel again.
April 11th, 1970. Launch day. The crew of Apollo 13. Jim Lovell, commander and veteran of 3 previous missions. He had orbited the Moon Christmas 1968 on Apollo 8. Fred Hayes, his first time up, lunar module pilot. Jack Swigert, command module pilot. 3 days ago, he was on the backup crew. Now he replaced Ken Mattingly. Mattingly had been dropped from the mission because he had been exposed to German measles. He would watch the launch from Houston's mission control.
Auto sequence initiated, flight.
Roger. Flight booster. No, S4B pre-press complete. Roger.
Flight booster. S1C pre-press complete. We're on internal power and we'll go.
Roger. How's it look, Econ? You got your space? Looks good, flight. Okay. MCC record us to flight speed.
Ignition, flight.
Roger. Roger. Clock start, flight. Roger.
Let's just go, all engines.
Roger. Okay, Fido, how's it look?
Looks good here, flight. Good agreement.
Okay, Booster, how do you look?
S1C looks good, flight.
Okay, Capcom, we go you on the ground. Okay, we'll go at 1, Capcom.
Get relieving, flight.
Roger. Booster, how do you look?
We look good, flight. We'll go.
Okay, Fido.
We're go, flight. Looks good here.
Guys, how's it look? Good, flight. Okay, Econ, GNC.
Looks good, flight.
Looks good, flight. Okay, Sergeant.
Looks fine. Through max Q and we'll go, flight.
Roger, Booster. And go for staging, Capcom.
Confirm and board out, flight.
Roger.
Staging, flight.
Roger.
Flight Fido, trajectory confirmed, staging.
Roger.
Flight booster, then board out was way early.
Okay.
Flight confirmed, number 5 engine down.
Roger. Booster, you don't see any problem with that, though, do you?
Negative, not right now, flight. All the other engines are go.
The next step in the routine of lunar flight was to burn out of Earth orbit toward the Moon, then pull free of the third stage and dock with the lunar module Aquarius. At the controls of the command module Odyssey, Jack Swigert.
We're hard docked, Houston. Roger, understand hard dock. Good deal.
They pulled Aquarius away from the Saturn third stage, the S4B.
Okay, I can see the S4B now at the hatch window.
Odyssey and Aquarius moved away from Earth toward the Moon.
Okay, Houston, we've had a problem here.
5 guidance. Go, guidance.
We've had a hardware restart. I don't know what it was.
Okay.
Houston, we've had a problem. We've had a main B bus undervolt.
You see an AC bus undervolt there, guidance? Or, ECOM?
Negative, flight.
Believe the crew reported it. We got a main B undervolt.
We may have had an instrumentation problem, flight.
Roger.
And we had a pretty large bang associated with the caution and warning there.
The sensation I had, that I had felt a vibration accompanying the bang, not a large vibration or shudder.
Is there any kind of leads we can give them? Are we looking at instrumentation, or we got a real problem, or what?
We're reading 0 N2 pressure in fuel cell 1 and 13 psi on fuel cell 3 O2 pressure.
Okay, Barrett, what do you want to do? Open circuit fuel cell 1 and 3?
That's firm flight.
Shut down the reactance valve, and I asked for a reconfirmation, since when you do that, it's sort of irreversible. If you shut one of these things down, they only can be restarted from ground support equipment.
Yeah, that's because of AC. And it looks to me, looking out the hatch, that we are venting something. We are venting something out into space.
Okay, let's everybody think of the kind of things we'd be venting. GNC, you got anything that looks abnormal in your system?
Negative flight.
How about you, Ecom? You see anything that, with the instrumentation you got, that could be venting?
That's firm flight. Let me look at the system flight as far as the venting is concerned.
Okay, let's start scanning.
Here is a bulletin from ABC News. The Apollo 13 spacecraft has had a serious power supply malfunction that could cause the lunar landing mission to be terminated early.
I assume you've called in your backup ECOMs?
Flight, say again?
Have you called in your backup ECOMs now? See if we can get some more brain power in this
We
thing?
got one here.
Roger.
At the moment, the astronauts are continuing to try to isolate their trouble. The late report says the spacecraft now is operating on battery power alone. All unnecessary equipment is being turned off.
Okay, now let's everybody keep cool. We got the LEM still attached. The LEM spacecraft's good, so if we need to get back home, we got a LEM to do a good portion of it with. Okay, let's make sure that we don't do anything that's going to blow our CSM electrical power with the batteries, or that will cause us to lose the main or the fuel cell number 2. Okay, we want to keep the O2 and that kind of stuff working. We'd like to have RCS, but we got the command module system, so we're in good shape if we need to get home. Let's solve the problem, but let's not make it any worse by guessing.
My concern was increasing all the time. It went from, I wonder what this is going to do to the landing, to I wonder if we can get back home again.
Okay, I'm coming back to you.
Flight.
Go ahead.
I think the best thing we can do right now is start a power down.
Right about then, it was quite apparent to me that it was just a question of time that the command module was going to be dead.
You don't want to get fuel cell pumps off, do you?
We can do that on fuel cell number 1 flight.
Okay, well, let's make sure we don't blow the whole mission. The thing that concerns me is throwing equipment. We had a problem. We don't know the cause of the problem.
Flight, I've got a feeling we've lost 2 fuel cells. I hate to put it that way, but I don't know why we've lost them. It doesn't all tag up.
Network from Flight.
Flight network.
Bring me up another computer in the RTCC, will you?
We got one machine on the RTCC, and we got dual CPs downstairs.
Okay, I want another machine up in the RTCC, and I want a bunch of guys capable of running D-logs down there.
Roger that.
What all this means is only speculation at this point. First, though there has been some tumbling or rotation of the spacecraft, the astronauts do not appear to be in any immediate danger.
I'll tell you what, GNC, can you get somebody in the back room to try to figure out what the equivalent delta V is we're getting, so that we can see if we can backtrack to see if we can figure out what's venting? Roger, we'll give it a try, Flight. Okay?
When I looked up and saw both oxygen pressures, one absolutely 0 and the other one going down, it dawned on me, and I'm sure Jack and Fred about the same time, that we were indeed in serious trouble. The only way to survive the situation was to transfer to the LEM.
Flight Econ.
Go ahead, Econ.
The pressure in O2 tank 1 is all the way down to 297. We better think about getting in the LEM or using the LEM systems.
I'd say this is as serious a situation as we have ever had in manned space flight. We've always called the LEM a good lifeboat under those circumstances. If at any time in the mission, however, the LEM had separated and we had gotten ourselves into a rendezvous situation, or the command module being around the moon, then what you state is absolutely true. It would be a fatal situation.
Tell me you from Flight. Go ahead, Flight. I want you to get some guys figuring out minimum power in the LEM to sustain life.
The accident had occurred 200,000 miles from Earth. Lovell, Swigert, and Hayes rode in the lunar module attached to a lifeless command module. Apollo 13 had started as a mission of scientific exploration. It was now a matter of survival. Since the command module was dead, except for the oxygen and power hoarded for re-entry, the guidance platform of Aquarius, designed to land on and take off from the moon, would have to be used.
The first milestone, and I consider this after the accident, I guess, more or less the survival now. The first milestone was to get alignment on the LEM platform. Alignments are important, you know, because without knowing exactly which way the attitude of a spacecraft is in space, there's no way to tell how to burn or how to use the engines of that spacecraft to get the proper trajectory to come home.
The position we are now on the Earth-Moon plane, we have to go around the moon to get back if we're going to use the DIPS engine. You would have had enough capability with the SDS engine, but of course we don't dare use that now. So we have to go to the back side of the moon and come back.
To get into the correct orbit around the moon, the crew had burned out of a trajectory that would automatically bring them back to Earth. They would have to get back onto a safe course toward Earth.
He needs to put his throttle to min also, Flight. Throttle to min? Yes, he's at 29% now, roughly.
This maneuver, again, was completed on time, and because it was a manual burn, we had a three-man operation. Jack would take care of the time. He'd tell us when to light off the engine, when to stop it. Fred handled pitch maneuver, I handled the roll maneuver, and I pushed the buttons to start and stop the engines.
Aquarius, and you go for the burn. Okay, Aquarius, you're looking good. Auto shutdown.
The first problem was solved. They were back on the path to Earth. But there were many other problems to be solved. From a building at Houston's Manned Spacecraft Center, systems experts coordinated the coast-to-coast effort to get the crew back. One of the big problems was consumables. There would be enough to eat and drink. But in space, there are other factors. Oxygen to breathe, electrical power to keep the spacecraft alive, water to cool the equipment and keep it operating.
What we'll be doing till we get them back on the water is concentrating on everything that is their lives are dependent upon at the moment, rather than worrying about the accident, because there's nothing we can do about that now. It appears at the present time that everything is under control and that we have a safe situation at the moment.
Hey, I want to say you guys are doing real good work.
So are you guys, Jack.
We are about 70 hours from home, and we think we have the situation in control. We've projected the consumables as I've described, and we have a plan for carrying out the rest of the mission, but there's going to be no relaxation at all as far as that goes from now until splash.
There was a key decision to be made before Apollo 13 went behind the moon. Where to bring them down. Their present course would take them to the Indian Ocean, where recovery would be difficult. A burn to bring them home quicker would take them to the Pacific Ocean near the recovery forces. Bringing them home even faster would place them in the South Atlantic, again away from recovery forces. It was decided to take them to the Pacific.
We've run these simulators both here and at the Cape and at the contractors that continuously ever since last night. We've tried to simulate virtually everything that we've had the crew to do that is non-normal that they've done, and we've proven most everything that we've been able to run on the simulator prior to passing it up to them. Now, there may be some details we haven't done, but at least we've checked the feasibility of everything we've done, and we'll continue to do that.
They passed 137 miles from the moon. For Lovell, it was the second time that he had seen the moon so near. But there was no time for contemplation. There was another critical burn coming.
Okay, look, let's
And in Houston, the newsmen poured in to tell an anxious world the story.
Well, that was going along with the ignition time.
Shortly after Apollo 13 had separated from the Saturn third stage, the stage had been sent onto a trajectory toward the moon. Its impact would be recorded by the seismometer left by Apollo 12.
By the way, Aquarius, we see the results now from 12's seismometer. Looks like your booster just hit the moon and it's rocking it a little bit. Over.
Well, at least something worked on this flight. I'm sure glad we didn't have a limb impact, too.
Jim, you go for the burn. Go for the burn.
Roger, understand. Go for the burn.
Guidance okay? We're good, flight. Control okay? We're okay, flight. Tell me we're go, flight. Inco okay? We're good, flight. Ground confirms ignition.
We're burning 40%.
West Houston, you're looking good.
Roger. Shut down.
Roger, shut down. I say that was a good burn.
Roger, now we want to power down as soon as possible.
Understand.
To conserve the electric power and cooling water, the crew shut down all but the vital life-sustaining systems of the LEM.
I think the LEM spacecraft's in excellent shape, and I think it's fully capable of getting the crew back. I think, as we have found before, every time we've put the LEM spacecraft to a test, it's always done much more than it was guaranteed to do, and I think this is a good case in point.
Conserve the consumables, cooling water, electric power.
The LEM water gun was leaking, and we shut that off. I guess it leaked about a quart of water, I would estimate. But it took me about 2 days to get my feet dry, and of course, I think you were all aware that the temperatures were going down in both vehicles, and it's made for very chilly feet for a couple days.
Ok, au revoir.
Lord, your astronauts will come back safe.
If I may be serious for one moment and ask the entire audience for a moment of prayer for the crewmen of the Apollo 13. We'll hold silence for a moment, please.
RCS-A stands at 62% and B at 62%.
I feel we've gone a hell of a long time without any sleep. We have to start thinking about getting people back to sleep again because I didn't get any sleep last night at all.
Command module just slowly kept going down in temperature until I think just prior to reentry, it was down to about 38 degrees. And along with that, there was a sort of a chilling coldness. The walls were perspiring, the windows were completely wet, and it wasn't too healthy. I recall that we went in there to get some hot dogs one day, and it was like reaching into the freezer for the food.
So if you want my opinion of how they handled the situation when it happened, they handled it exactly like we'd expect them to. They were about as well on top of it as anybody could be, knowing what we knew, which isn't very much, I'll have to admit. but I think they did everything right within the knowledge that was available to us in a timely fashion, which is what all we expect of them. I think they did a beautiful job of it.
We actually had a third little sleep restraint, which Fred then put on and buttoned up and kept a little bit warm.
The astronauts faced another problem, their own exhaled breath. The lithium hydroxide chemical to take carbon dioxide out of the air was not sufficient in the lunar module. They would have to adapt the canisters from the command module to fit the hoses in the LEM. On the ground, an adapter was fashioned from materials the crew had available in the LEM. Cardboard from a checklist, plastic bags, and tape. After checkout in an environmental chamber, the directions for construction were sent up to Aquarius.
At this point in time, I think the partial pressure of carbon dioxide was reading about 15 millimeters. And we constructed 2 of these things and put them online, and I think within an hour, the partial pressure of CO2 was down to 2/10.
So you see that survival now became one of initiative and ingenuity, and it was one which the ground continually helped us along. We had all kinds of people on the ground trying to think up ways of extending our lifetime.
There would be still another burn, a mid-course correction to get Apollo 13 into the narrow corridor through the atmosphere for a safe return to Earth.
We're at burn attitude, flight. Knowledge.
Ignition. Thrust looks good. Shut down.
Hang in there, it won't be long.
There were moments when I didn't know how much consumables we had, whether we could make it back or not, but in a situation like that, there's only one thing you can do. You just keep going, and you just keep thinking up where you can get more consumables. And so that's exactly what we did.
On April 17th, they prepared for re-entry. After a small course correction burn, they jettisoned the damaged service module.
Step. Copy that. And there's one whole side of that spacecraft missing.
Is that right?
The whole panel is blown out, almost from the base to the engine.
It's really a mess. Man, that's unbelievable.
Next, they got back into Odyssey to jettison Aquarius prior to entry into the atmosphere.
Left jettison.
Okay, copy that. Farewell, Aquarius, and we thank you. Okay, LOS in a minute or a minute and a half. At entry attitude, we'd like Omni Charlie. And welcome home.
Thank you.
Odyssey Houston standing by, over.
Okay, go over.
Odyssey Houston, we show you on the mains. It really looks great.
Apollo 13, this is recovery, over. They're going through 5,000. Under Apollo 13, this is recovery, and your chutes look good. Apollo 13, this is recovery. We observed your RCS burn, over. The recovery, Apollo 13 is descending. Apollo 6, this is recovery, over. Photo 1 spliced in at this time. The three chutes are displaced in the water. Our 0 degrees magnetic 3.5 miles. Zero, Lima. Zero, roger. This Photo 1, the command module is stable 1 at this time. They're riding comfortably. The vertical axis are approximately 15 degrees. Swim 1, you're clear to
I recall, Captain, that when I spoke to you on the phone, you said that you regretted that you were unable to complete your mission. I hereby declare that this was a successful mission. From the start, the exploration of space has been hazardous adventure. The voyage of Apollo 13 dramatized its risks. The men of Apollo 13, by their poise and skill under the most intense kind of pressure, epitomized the character that accepts danger and surmounts it. Theirs is the spirit that built America. Your mission served your country. It served to remind us all of our proud heritage of a nation, to remind us that in this age of technicians and scientific marvels, that the individual still counts, that in a crisis, the character of a man or of men will make the difference.
GNC. Go. Surgeon. Go. Procedures. Go. AFD. Go. Network. Go. Computer soup. Go. Raj, network, give me an amber. RTC on AFD conference. RTC's on the AFD conference. Okay, all flight controllers, let's play it cool.
5 miles above the moon, Dave Scott and Jim Irwin looked out the window of their lunar module down toward Al Warden in the command module, which had completed its separation maneuver. Beneath them, the 15,000-foot peaks of the lunar Apennine Mountains. Soon they would fly low over those peaks on their way to a landing in a little valley in the mountains of the moon.
Coming up on pitch over. P64. Okay. We have LPD. LPD. Coming right.
Out their window, they could see the sinuous meanderings of the lunar canyon known as Hadley Rill as they brought their lunar module, call sign Falcon, toward its landing, and the beginning of what would be one of the most significant chapters in the history of scientific exploration.
9% fuel. 200, minus 11. 150, minus 7. Minus 6. 120 feet, minus 6. Minus 5, 100 feet at 5. 9% fuel. Minus 5. 80 at 5. Minus 3. 60 at 3. 50 at 3. Cross pointers look good. 40 at 3. 33. 25. 2. Okay, I've got some less. 7% fuel. 20 at 1. 15 at 1. Minus 1. Minus 1. 6% fuel. 10 feet, minus 1. 8 feet, minus 1. Contact. Bam! Okay, Houston, the Falcon is on the plane at Hadley. Roger, roger, Falcon. No denying that. We had contact. Houston, the Hadley base here. Tell those geologists in the back room to get ready, because we've really got something for them.
Scott and Irwin were located on an undulating plain situated between the Apennines and Hadley Rill, an area selected by the scientists as being one of the most geologically significant sites on the moon.
Okay, overhead hatch is open and ledge.
2 hours after touchdown, Dave Scott stood up in Falcon's upper hatch to survey their landing area.
Oh boy, what a view. I can see Pluton and Icarus.
As Scott stood describing the craters and mountains, we on Earth perhaps did not yet realize the scope and extent of the coming mission. Aboard the lunar module was a small dune buggy-like car called the Lunar Roving Vehicle, or just plain Rover. The astronauts would travel miles in collecting samples and placing and conducting experiments.
There are no sharp, jagged peaks. There are no large boulders apparent anywhere.
They would observe the layering of the lunar terrain, most clearly seen in the formation 14 miles to the south, called Silver Spur. This layering, later to be observed in the mountains and the rill, gives scientists a direct look at the structure of the moon and a deeper insight as to the significance of the collected samples. The journey of Apollo 15 had begun 4 days earlier, July 26, 1971. The crew, Dave Scott, spacecraft commander and veteran of Gemini 8 and Apollo 9. Jim Irwin, lunar module pilot, who would explore Hadley Rill and the Apennine front with Scott. Al Warden, command module pilot, who would remain in lunar orbit operating an extensive array of cameras and experiments and making observations which, when coupled with the surface work of Scott and Irwin, would give the most comprehensive picture of the moon's structure and history ever achieved.
We have complete clearance to launch. We are go. 15 seconds. Guidance internal. 13, 12, 11, 10, 9, 8. Ignition sequence start. Engines armed. 5, 4, 3, 2, 1. All engines running. Launch commit. Liftoff. We have liftoff at 9:34 a.m. Eastern Daylight Time. The tower is clear.
And we have a roll program. Roger.
Precisely on schedule, 9:34 a.m., Apollo 15 lifted from the pad on its way to the moon.
And we have a pitch program.
Roger. Roger.
With the exception of a few minor problems, the trip out would be uneventful. The command module Endeavour, carrying the lunar module Falcon, would arrive in lunar orbit with Scott's announcement,
"Hello, Houston. The Endeavour is on station with cargo, and what a fantastic sight. Oh, this is really profound. I'll tell you, this is absolutely mind-boggling up here."
Gentlemen, I can well imagine that a foreign planet must be a weird thing to see.
July 31st. After a night's rest, Dave Scott descended into the lunar morning.
Okay, Houston, as I stand out here in the wonders of the unknown at Hadley, I try to realize there's a fundamental truth to our nature. Man must explore. And this is exploration at its greatest.
Scott was then joined by Jim Irwin.
Oh, boy, it's beautiful out here. Reminds me of Sun Valley.
Their first job was to get the lunar roving vehicle out of its storage bay.
Looks like she's coming down okay. No. Hey, can you pull it out a little bit, Jim? About that. That looks good. Boy, is this dirt soft. Like soft powder snow.
Next, the astronauts tried out the rover. During this test drive, one failure showed up. The rover was designed to steer through both its front and rear wheels.
But I don't have any front steering, Joe. Like this rear steering, Dave. Yeah.
In use, the absence of front wheel steering would hardly be noticed. Then they loaded the equipment they would need for their geological survey and boarded the rover for their first exploration.
Okay, we're moving forward, Joe. Roger.
They were headed toward St. George Crater, located on a mountain slope above Hadley Rill to the south of the landing site. There would be a stop to collect samples at a smaller crater called Elbow, then arrival at the base of St. George. and a look into Hadley Rill.
Oh, look at that. Oh, look back there, Jim. Look at that. That's beautiful. That is spectacular. This is unreal. The most beautiful thing I've ever seen.
Scott then adjusted the television antenna on the rover. 250,000 miles away, in Houston's Mission Control, a flight controller operated the television camera mounted on the rover. Scientists and engineers on Earth could directly monitor the lunar exploration. And those of us at home watching on television felt like the third astronaut on the moon.
That looks fairly recent, doesn't it? It sure does. Okay, now we got the fillet, we got the soil, now we need to sample the rock. Yeah.
The astronauts began to collect samples and photograph the area. The samples would consist of rocks picked up with a rake-like device, soil samples, selected rocks, and chips taken from boulders.
Can you imagine that, Joe? Here sits this rock, and it's been here since before creatures roamed the sea on our little Earth.
They would also drive core tubes into the lunar soil to collect contiguous specimens from beneath the surface. But now it was time to return to the lunar module. Not to end this first work period on the lunar surface, but to begin another phase.
I can't believe we came over those mountains. We did. It's just a beautiful little valley. Yeah, those are pretty big mountains to fly over, aren't they?
After returning to the LEM to load equipment, they moved to a nearby location to set up a science station similar to those left on previous missions. With the establishment of these experiments, a network of scientific stations was achieved which would allow triangulation of events and give us the ability to locate precisely the origin of lunar events. As they worked, one of their instructions was to throw the packings as far as possible from the site. Dave Scott.
I'll give you a demonstration here, Joe.
Roger. Right on.
Here, Joe.
Spectacular demonstration.
Oh, well, enough of that.
Lovely. What was that a demonstration of, by the way? It started out to be of gravity, and it wound up being of centrifugal force, I think.
Using an electric drill, Scott sank a tube into the lunar soil, into which a probe would be placed to measure heat flow in the lunar material. The difficulty in drilling would delay placement of the second probe until the next day. The science station was then activated. And Scott and Irwin closed Falcon's hatch on EVA number 1.
And Tsiolkovsky is big enough so that you do get some, at least optical impressions of the central peak being higher than the ridges, but I think it's just because the basin is
60 miles above the moon, Al Warden orbited in the command module Endeavour, operating experiments, his observations adding to the wealth of scientific data already accumulated.
Okay, I'm looking right down on Litro now, and a very interesting thing. It looks like a whole field of small cinder cones down here.
The detection of cinder cones, clearly of volcanic origin, helped solve another element of the controversy about how much of the moon was formed by volcanoes and how much by meteoroid impact. Warden was operating a series of experiments in the scientific instrument module. These included a mapping camera to shoot lunar features and simultaneously the star field for accurate location of these features, a panoramic camera, a laser altimeter for accurate topographical mapping, and a series of experiments to analyze the chemical makeup of the lunar crust. In the estimation of a number of scientists, this orbital research station would provide the most important information collected during the mission.
Down the ladder to the plains of Hadley.
August 1st, Scott and Irwin prepared for their second day on the moon. And as Scott checked the inoperative forward steering of the rover,
You know what I bet you did last night, Joe? You let some of those Marshall guys come up here and fix it, didn't you? It worked, Dave?
Their destination was the base of the Apennine Front. Here they hoped to find some of the basic substance of the lunar highlands.
Oh, as we drive up sun here, I can see Mount Hadley, and the linear patterns in it are really remarkable.
Then they began the physical sampling of the Apennine Front, stopping at 4 craters in their traverse.
Oh, boy. It's a nice little crater, isn't it? It sure is. Okay, Jimmy, let's go to work. Roger. Look at that. Almost see twinning in there. Guess what we just found? I think we found what we came for. Crystal and rock, huh? Yes, sir. You better believe it.
To the untrained eye, it looked like just another rock. But its large crystals, formed in pairs called twinning, showed it to be a section of primal lunar crust, formed during the earliest history of the solar system, not obliterated by billions of years of impacts and lava flows. It was a key to many mysteries. Was the early lunar crust molten? Why differences in color and density between the highlands and lowlands? Nicknamed the Genesis Rock, it stands as a major clue in unraveling the formative processes of the moon, the Earth, and the planets.
Make this bag number 196 a special bag.
Yes, sir.
Joe, this crater is a gold mine.
And there might be diamonds in the next one.
Yeah, babe.
Then we saw another practical use of television in lunar exploration.
And Dave, you're going to want to cinch up Jim's collection bag probably before you go much longer. It's coming very loose there.
Okay. Coming very loose. Let me do it right now, Joe, so we don't forget it.
Roger, we sure don't want to lose that one.
I don't know what we'll do without you, Joe. Okay, Jim, let's get on a rover and head back to Havre. It's nice to sit down in it. Oh, it is. Okay, and we're on our tracks.
Roger. And follow them home.
There's sure a lot of neat rocks in Dune. Too bad we can't spend some more time.
On your next trip.
Yeah, next trip, you're right. Making me seasick.
What do you expect traveling on the Mare?
They returned to the science station where Scott once more manned the drill to place the second heat flow probe and later to get a deep core sample. The difficulty in drilling was shown by Scott's hands, which would carry bruised fingernails from his efforts for several weeks after the mission.
Okay, Dave, take heart. You've got just 1 minute of drilling left.
Okay, we made a little money, didn't we?
Hand over fist.
It was time to get back into the LEM and end EVA-2. The drill and attached sections were left in the ground for removal during the next day's traverse. On Earth, scientists pored over data from the television, from the astronauts' descriptions, and from the orbiting experiments. The 1,400 photographs the crew would return would themselves constitute a major scientific legacy. Lunar exploration was achieving a new maturity. We are now exploring to test new hypotheses, and the pieces were fitting together. One scientist, when asked why he didn't sit down and rest after an around-the-clock session, replied, "I can't. I'm too excited."
Oh, it's nice to be outside where you can stretch a little bit. Okay. That's the site. Hey, I'll meet you up there. Down to the drill. We last left our friend. Oh, it's our friend, huh? Yes, it is. If we could just get our shoulder under that.
Their first stop was at the drill they had left during the second EVA. This core tube was the deepest sample ever collected from the moon, perhaps the deepest we would ever get. 8.5 feet beneath the surface, cutting through 58 distinct layers. This would not only tell us more about the lunar structure, but contained in this soil were traces of particles emitted by the sun billions of years ago, which would give us a clue to the early years of the solar system. But now it was time to leave the core tubes to be picked up later and head west-northwest to the rim of Hadley Rill.
Look at that rill. How about that? I can see maybe 10 very well-defined layers within that unit. Hang on. Yeah. All right. Yeah. Pretty soft, but I stumbled over the rock.
Then Scott and Irwin descended a short distance over the rim of Hadley Rill to get a piece of one of the large blocks thought to be lunar bedrock.
A big rock there. Sure is. Let's go down and get a chunk of the bedrock here. Get a little closer so you get that big chip out of there. Boy, what a rock. Get ready to move out, Dave? Yep. Yeah. Stepping here for the next guy. Okay, hop on and we'll get on with it here.
They buckled their seat belts for the ride back to the lunar module.
Oh, what a big mountain that Hadley is. Yeah, it's beautiful. Sun is really fierce. Oh, look at the mountains today, Jim, when they're all sunlit. Isn't that beautiful? Really is. By golly, that's just super. You know, unreal. Dave, I'm reminded of a favorite biblical passage from Psalm. I look unto the hills from whence cometh my help. But of course, we get quite a bit from Houston, too.
After a stop to pick up the core samples, they returned to the LEM to close out their final traverse. But first, Scott would make history, canceling a stamp on an interplanetary envelope.
I'm very proud to have the opportunity here to play postman. What could be a better place to cancel the stamp than right here at Hadley Rill?
Then a demonstration of a classic experiment.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? How about that? Proves that Mr. Galileo was correct in his findings.
Finally, Scott drove the rover away from the LEM so that its TV camera could pick up a picture of the coming liftoff.
As the space poet Reisling would say, we're ready for you to come back again to the homes of men on the cool green hills of Earth.
Thank you, Joe. We're ready too. But it's been great.
171 hours and 37 minutes after they had lifted off the planet Earth, Scott and Irwin would lift off its sister planet, accompanied by a musical salute they themselves would provide from a small tape recorder on board.
Good liftoff. Automatic. Hey, good smooth ride, Ed. Almost sounds like the wind whistling, doesn't it? Oh, what a view of the rill, huh? Older tracks coming down into it.
The rendezvous and docking procedures were flawless, right on the money. But their jobs were not over yet. They would spend 2 more days in lunar orbit gathering data from the experiments and photography. 1 more day around the moon than any preceding mission. On August 4th, they prepared to come home. But even on their last orbit of the moon, they had another experiment.
3, 2, 1, launch. A very pretty satellite out there.
They placed in orbit a sub-satellite, the first ever launched by a manned spacecraft. It was designed to circle the moon for a year, measuring variations in lunar gravity, the strength and direction of interplanetary and Earth magnetic fields, and the flow of charged particles in space.
Tracking stations have acquired the satellite.
Oh, very good.
Then the burn to bring them back to Earth. But their jobs were far from over. 172,000 miles from Earth, Al Warden left the spacecraft to retrieve the 8,000 feet of film contained in the cassettes of the experiment bay cameras. Later, they would turn their X-ray spectrometer toward the newly discovered X-ray pulsars, those mysterious black holes in space. At the same time, in accord with the previous plan, an Earth-based Soviet observatory scanned the same areas visually to help derive a model consistent with both sets of observations. During the trip home, the X-ray spectrometer would observe 7 X-ray sources and gather 50 hours of galactic data. Then, on August 7th, they looked into the fireball created by the heat of their re-entry into the Earth's atmosphere at 25,000 miles per hour. And there would be a heart-stopping moment as one of the 3 parachutes collapsed. However, the landing system was designed to use 2 parachutes. The 3rd parachute was an added safety factor. Today, that margin paid off. The success of Apollo 15 had been spectacular. The scientific results have been almost unbelievable. In the words of one scientist, a 5-for-1 mission. Yet while we rejoice in our success, we cannot afford to forget the sometimes painful efforts that gave us these achievements. Spacecraft Commander Dave Scott.
I think many people have contributed to this pinnacle we've reached. Some have contributed more than others, and we know of 14 individuals who contributed all they had. And because of that, well, we left a small memorial on the moon. About 20 feet north of Rover 1, in a small subtle crater, there's a simple plaque with 14 names. And those are the names in alphabetical order of all the astronauts and cosmonauts who have died in the pursuit of exploration of space. Near it is a small figure representing the fallen astronaut. We went to the moon as trained observers in order to gather data, not only with our instruments on board, but with our minds. And I'd like to quote a statement from Plutarch, which I think expresses our feelings since we've come back. The mind is not a vessel to be filled, but a fire to be lighted. Thank you.
April 16, 1972. Apollo 16, man's 5th lunar landing, sat silently on the pad awaiting its mission. Inside the astronaut quarters, its relaxed crew ate Sunday breakfast. John Young, a veteran of 3 previous space flights, was commander. Ken Mattingly, command module pilot, would conduct orbital experiments around the moon, while Charles Duke explored the lunar surface with Young. April 22nd. Young and Duke would find themselves strapped into a small electric car called the Rover, bouncing across the lunar plateau known as Descartes.
The old water bag is working super. This is going to be a good day, Charlie. Yow! Woo! Man, that was great. Big skid. We're doing 10 clicks, Tony. Covered me with dust on that one.
As Young and Duke rode the bucking rover to the lunar formation called Stone Mountain, NASA geologist Farouk El-Baz wrote on a blackboard on Earth, "There is nothing so far removed from us to be beyond our reach, or so hidden that we cannot discover it." René Descartes. As John Young would later remark, Apollo 16 would certainly help prove that René Descartes was right.
Compacted. Almost like a freshly plowed field that's been rained on.
Yet, less than 2 days before, it looked as though this would never happen. It was, in Young's words, a real cliffhanger. The Marshall Space Flight Center team was working on a launch vehicle gyroscope problem that threatened to scrub the mission. Less than an hour before liftoff, their advisory to the Kennedy Space Center launch team was go. The liftoff had been perfect. During the 3-day flight to lunar orbit, the problems encountered had been more annoyances than critical, such as paint flaking off the lunar module, and later a jammed antenna in one of the lunar module's several communication systems. All in all, it had been a quiet flight. April 19th. The burn into lunar orbit was right on.
Houston, Sweet 16 has arrived.
The subsequent maneuvers all went without a hitch. Then the next day, April 20th, Young and Duke undocked the lunar module preparatory to landing, leaving Mattingly in the command module.
But we got it done right here 5-9, Jim, and we're sailing free. Stand by one, Jim. Okay, we're on time.
The next maneuver was for Mattingly to burn the main engine of his spacecraft to put it into a circular orbit. But as the lunar module emerged from behind the moon...
No, sir. Copy, no, sir.
No, sir. No, sir.
No circ. In preparing for the circularization burn, Mattingly had found apparent uncontrolled oscillations in the main engine's backup control system. Following mission rules, he did not make the burn.
How long do you think it's going to take them to get rendezvous, Jerry? I think your estimate of a couple of 3 reds.
With the backup system having trouble, only the primary system was known to be usable on the engine needed to get the astronauts out of lunar orbit and back to Earth. However, the lunar module engines could be used if the 2 spacecraft were docked. The first step in the problem-solving technique: stabilize the situation in the safest manner. Get the 2 spacecraft, which had separated, close enough together to dock, if necessary.
To get them back together, get the things back if they want them, get them mentally prepared to do what they're going to do.
But now, don't take that as input. I'm talking out loud. I want to say something I'm sure of.
I don't see any way we can continue on.
At that moment, the chances for a landing looked pretty slim. But you look at a problem step by step. Step 1 underway, you look at step 2. Analyze the problem as completely as possible within the time frame.
We should make sure that that's gone, but there's no way that you don't have any other redundancy or other routes.
And in lunar orbit, Mattingly flew the command module to a rendezvous as Young talked him in.
Okay, Ryan, why don't you tell me what to do there, John? Okay.
Word's coming back kind of initially from North American that they're suspecting a rate feedback.
Building 45 Jim McDevitt.
The team was coming up to speed, not only at the Manned Spacecraft Center, but from MIT in Massachusetts to North American in Southern California. Isolate the trouble, simulate it, evaluate it.
You can't use it if you got a broken wire. You don't know what's going to come back again.
You now like I'm drifting the other way. Not according to my needles. Okay, I'll believe your needles.
Of course, then you would have had no options. Okay. Go ahead. I mean, then it's full speed ahead.
I just don't much see how we can make it on this next rev. I think you guys ought to continue to work.
So you'd only do it if you had a failure on the primary. Well, how would you ever get the damn thing trimmed then?
Well, I would. If I had a failure in a primary, I'd shut it down.
Well, we must be going in the right direction then. Yeah, you're going to get there.
Yeah, but I want you guys to go simulate it.
Isolate, simulate, evaluate. The results were coming in. It was beginning to pay off. The simulator tests and other data were showing that with the engine on, the oscillations would do no harm. Despite the earlier pessimism, it was beginning to look pretty good.
Okay, when you come up on AOS, on the next Rev 15, we'll give you a go or no-go for another try.
Manned Spacecraft Center Director, Dr. Christopher C. Kraft, Jr., just came back into the control center after having attended a meeting by management people in one of the back rooms, and the situation is go for landing.
Well, have at it, babe. So we're going to try. You do have a go for another try here at PDI on Rev 16.
Once more, they would pass behind the moon. And on the next revolution, John Young and Charlie Duke would start their swift descent to the Descartes Plateau.
Okay, filter initialization looks good.
Right on. Feel that beauty? Come on. 200. Pro. Pitch over. Pitch over. And here it is, Gator, Lone Star. Right on. I'll be the thanks, Charlie. Okay, 40 degrees, 38 degrees. Right on dot, North Ray. Okay. Looks like we're going to be able to make it, John. There's not too many blocks up there.
Ryan, you go for landing.
Right now looks pretty good.
Go, Hunter. Okay, any words in
Go, Flat. Looking good. It looks good.
That comes the shadow. Okay, down at 3, 50 feet. Down at 4. Give me one click up. You're backing up slightly. Okay, 2 down. Stand by for contact. I'm going to let her down. You level off. Let her on down. Okay, 76%. Plenty fat. Contact. Stop. Boom. Wow! Oh, man! Oh, a run is finally here, Houston. Fantastic.
The original plan had called for Young and Duke to get out and explore shortly after landing. However, the near abort had lasted 6 hours. The tired astronauts would sleep. April 21. Mission Commander John Young stepped onto the Descartes formation. 11:58 a.m. Eastern Standard Time.
They are mysterious and unknown Descartes. Island planes. Apollo 16 is going to change your image.
While their activities were monitored by mission control, Young and Duke were also observed by scientists located across the hall in the science support room. After unloading the rover from its storage bay in the lunar module, they planted the flag.
Hey, John, this is perfect with
with the LIM and the rover and you and Stone Mountain and the old flag. Come on out here and give me a salute. Big Navy salute. Off the ground, before. There we go. Dead.
Young set up an ultraviolet camera to provide the first astronomical observations from the moon. He took pictures of the Earth's upper atmosphere and magnetosphere and their interaction with the solar wind. He also photographed the interstellar gas present throughout space and the ultraviolet halos that appear around galaxies. Astronomers have long wanted a telescope on the moon. Perhaps this experiment would show the moon an ideal base for future astronomical observations.
You want 2 pins?
Yeah, we would like to. John, sir.
I'm not leaning on
Duke
it.
drilled a hole into which a heat flow probe was to be placed, part of one of the experiments attached to the station. As Duke drilled, Young set up the central station and the remainder of the experiments. Then, what many considered the biggest disappointment of the mission.
Just some rocks down there in the regolith, Tony. You know, it looks, I bet it's just like the side of that fresh crater we saw back near the limb.
Charlie, what? Something happened here. What happened? I don't know. Here's a line that pulled loose. Uh-oh. What line is it?
That's the heat flow. Pull it off.
Yeah, sorry. I didn't even know it. I didn't even know it.
But that means you've got to mate all those wires, separate wires in there, and have them insulated from one another.
That's right.
And if that doesn't occur, what are the chances of shorting out the central station?
Well, that's another one that they're working.
On Earth, they tried to figure a way to fix the heat flow. On the moon, the astronauts continued with the other experiments. Young placed a series of sensors in the soil, then fired explosive charges, mapping the lunar subsurface much as geologists on Earth use explosives to search for oil.
4, 3, 2, 1, fire.
Stuck in the ground and I try to get this
three over there now.
the whole
They continued to sample the area and activate the experiments. Then they returned to the rover and prepared for their first trip away from the landing site in search for geological samples.
And here we go.
Their first traverse would take them about 1 kilometer west of the landing site. They would make 2 stops to collect samples and conduct experiments.
That's 10529 in your flight plan.
But it couldn't pick a better spot.
John, you're just beautiful. That is the most beautiful sight.
What's that?
You're standing there on the rim of that crater.
This guy don't really know. You're going to have to use the amp.
Young used a portable instrument to measure the local magnetic field. He would later record the most intense magnetic field ever found on the moon, far higher than scientists ever suspected.
It's really some crater.
As you come around there, there's a rock in the near field on this rim that has some white on the top of it. We'd like you to pick it up as a grab sample.
This one right here?
That's it.
This one right here?
That's it. You got it right there.
Okay, we copy that.
There would be one more stop before they got back to the lunar module to close out this EVA. With Duke acting as photographer and Young as driver, they put the rover through a full test.
Man, you are really bouncing.
Is he on the ground at all?
That's 10 kilometers.
Huh? He's got about 2 wheels on the ground. Okay, turn sharp.
I have no desire to turn sharp. Okay, here's the Sharpie.
Hey, that's great. He's a big rooster tail out of all 4 wheels. And as he turns, he skids, the back end breaks loose just like on snow. Come on Okay, the deck is running. And I'll tell you, Andy's never seen a driver like this. Okay, when he hits the craters and starts bouncing is when he gets his rooster tail. He makes sharp turns.
Then it was back to their lunar base, activate experiments, and close out EVA-1.
P-wise exercise there, right? Physical fitness, gym level. Hey, that's right. Please don't take pictures of the hot dogs. Showing the low residue, high protein diet.
On Earth, the scientists took a break. Tomorrow would be another busy day. April 22nd.
The lunar surface temperature in the sun should be around 135 degrees today.
Today they were headed a little over 4 kilometers south to climb their rover up the side of Stone Mountain.
Man, we're really going up a hill, I'll tell you.
Their first station, a crater 700 feet above their lunar module.
Wow, what a place. What a view, isn't it, John? It's absolutely unreal. We really come up here, Tony. It's just spectacular. I have never seen it. All I can say is spectacular, and I know y'all are sick of that word, but my vocabulary is so limited.
Well, let's see what we can do. If we've got the rake soil, we've got certainly something. We could go to one-man sampling and maybe do it.
They would make a total of 6 stops on this traverse, collecting samples from large rocks down through the intermediates to the smallest soil particles. They would operate experiments measuring the strength of local magnetic fields to measuring the resistance of the soil to compaction.
3, 4, 5, 6.
How far away is that crater?
Man, we come a long way. Hey, John, it's easier to go straight across. That was fun. Well, I haven't had any trouble. Okay. I have a tough time walking up there.
The sampling time used up, it was time to return to the rover and head back to the lunar module.
And they did it in 2 minutes less travel time than they were pre-planned. Fantastic.
Tony, how about an extension, you guys? We feeling good. Dad all we're going to do tonight was sit around and talk.
But with the limited oxygen and water in the backpacks, it was finally time to close out EVA-2.
Okay.
Now I think they realize that it's not more, a gee whiz, like my friend said, thrill, but it's real exploration, and this is much more serious and much more important for the future of mankind than just a plain exploit, a technical or technological exploit. This is exploration.
Ray Bradbury claims that what mankind sees in the exploration of space is his first chance at immortality since he invented religion.
April 23rd. The decision had been made not to try and fix the broken heat flow experiment because of the time and complexities involved. Traverse number 3. Today, Young and Duke would head north about 5 kilometers to North Ray Crater, the largest lunar crater to be sampled by men.
Outstanding.
Hey, Tony, it seems to me this is a more subdued surface over here than going towards South Ray. Oh, spectacular. Just spectacular. Wow.
Sorry, Charlie.
Beautiful.
I got to keep my eye on the driving.
That's great.
Jack, that's a good point to remember. All 3 crews now tend to think they're there before they get there.
I remember.
Man, does this thing have steep walls.
They said 60 degrees.
Now, I tell you, I can't see to the bottom of it, and I'm as close to the edge as I'm going to get. That's the truth.
Now the routine, if anything on the moon can be called that. Test, collect, photograph. Keep moving. Time is precious on the moon.
Crater. They look like drill holes is what they look like. You do that in West Texas and you get a rattlesnake. Here you get permanently shattered soil.
How about rolling that one over?
No way.
Then, one of the most spectacular discoveries of the mission.
Look at the size of that biggie. It is a biggie, isn't it?
It may be further away than we think.
No, it's not very far. It was just right beyond you.
And we better press on for the big boulder?
Okay, we're headed that way. You get the tongs, John?
Yep.
I'll carry the rake.
That big black dot.
Fantastic. Right here.
If we could see to the bottom, we could say for sure if this big black rock is right out of the bottom. But my guess from the old photographs is it probably is.
Okay, that sounds like a good guess.
God, you mean they weren't at it? No. It looked like they were standing right there.
Look at the size of that rock.
Curious what they're going to look like when they stand next to it.
We can see.
The closer I get to it, the bigger it is.
Yeah, but look at the permanent shattered part, Charlie.
On this side over here?
Yeah.
And as our crew slowly we bet upon it, disappeared into the sunset.
Well, Tony, that's your house rock right there.
Very good. Don't get too near the edge of that thing. It falls off. Look over at your right. It falls off pretty good.
Yeah, I know.
Yeah, we
Keep
should
going.
Can't believe
Got it. I can't either.
Okay, let's go on back.
I am. Be right with you.
And we'd encourage you just to look for some variety.
But now it was time to head back to their base and close out the EVA.
All right, we think you could just about head south now.
Yeah, the only reason.
That's it. We're going,
Home again. Jiggity jig.
During the previous EVA, a section of a rear fender had come off the rover, causing the astronauts to receive occasional showers of lunar dirt.
and that's a beautiful sight.
Young parked the rover, then moved out to join Duke, enter the lunar module, and prepare for liftoff.
Boy, Houston, the beauty of this place is just absolutely incredible.
Smile, FAO. Don't be mad. We'll get it up there. See how nice and leisurely it's been? That's the way it should be, getting ready for ascent.
10 seconds.
What a ride, what a ride. Liftover's on time.
Together in orbit, the two spacecraft pirouetted, each inspecting the other.
This is one of the fastest maneuvers I've made in a long time.
The inspections complete, the command module and lunar module maneuvered to docking. John Young, Ken Mattingly, and Charlie Duke, reunited aboard the command module, settled down for tomorrow's tasks. Jettison the lunar module and burn out of orbit to come home. April 25. Ken Mattingly left the confines of the command module cabin, 173,000 miles from Earth. As he orbited the moon, he had not only made visual observations, he had been operating a complex series of experiments. Many of these had returned instant data to Houston. 2 had taken thousands of high-resolution pictures of the lunar terrain. Now, Mattingly retrieved the film canisters and made his way back to the cabin with them. as Charlie Duke stood in the hatch to help him. It had been quite a mission. In John Young's words,
I think we've seen as much in 10 days as most people see in 10 lifetimes.
April 27, the last day. The crew looked out their windows through the 5,000-degree fireball of re-entry at their native planet.
Apollo 16, this is recovery. Welcome back. Go ahead.
That is beautiful, isn't it?
Now they're blooming. Beautiful. There they are. Beautiful.
Apollo Control Houston, an observer on the Ticonderoga estimates the distance from the ship about 1 mile.
You saw an example of goal-oriented teamwork in action. The kind of thing that made this country great and the kind of thing that's going to keep it that way.
A real smooth shot. Every bit of it. Gary? You brought him in beautifully. Well done, young man. Outstanding.
I cannot touch that cigar anymore. I cannot.
I told him they're going to improve the Skylab. We're in trouble. Mike, congratulations. Well done.
Yeah, we get one more.
Well done.
One more to go.
December 6, 1972. Eugene Cernan, veteran astronaut and commander of Apollo 17. He would be the last Apollo astronaut to stand on the surface of the moon. Dr. Harrison Schmitt, better known as Jack. He would be the first geologist to set foot on an alien world. Ronald Evans, command module pilot. He would remain in lunar orbit, operating a battery of experiments that would take this last close look at the moon. In the year 1675, Sir Isaac Newton was asked by his fellow scientist, Robert Hooke, how he had accomplished so much. "If I have seen further," Newton wrote, "it is by standing on the shoulders of giants."
Propellant tanks have been pressurized. The engines will build up to a thrust of 7.6 million pounds. T-minus 30 seconds. We have a cutoff. We have a cutoff at T-minus 30 seconds. This cutoff was automatic, done by the sequencer.
One command, pressurized S4B stage, was not given. And despite the fact that it was going to be done manually, the sequencer, in effect, said, I didn't tell you to do it, and therefore you can't be doing it. So at 30 seconds, it very properly stopped the operation. Most of the work was being done right off the firing room in the Launch Control Center at Kennedy. However, there was a great deal of support from the Marshall Space Flight Center, who had a comparable operational group working there with their contractors. So we concluded that we were safe, and we gave the word to jump route to one signal and proceed, which we did.
Houston, you are go for orbit. Go for orbit.
Those are kind words, Robert. We're go for orbit here.
After checking out the spacecraft in Earth orbit, they burned out of orbit and headed toward the moon.
Houston, we're right in the middle of a snowstorm. We're not there yet. Long way.
Ron Evans, at the controls of the Command Module America, moved in to dock with the lunar module Challenger. They pulled Challenger free of the booster's third stage, then continued the 3-day coast to the moon.
GNS, ATM, ECO.
Even as Cernan, Evans, and Schmidt headed toward the moon, directly below the Apollo 17 control room, Flight Director Don Putty ran his crew through a launch simulation for the first Skylab.
As you're probably well aware, we are still working on other programs, Skylab being the prime effort starting in the spring of next year. We're also working on the cooperative mission with the Russians, which will take place in 1975. And of course, we've got quite a few of the flight control team as well as other center elements involved in the work on the shuttle. So it's the start of a new era, I hope.
Skylab, of course, will fly in the spring of next year with 3 men going up and spending 28 days, and then 2 months later after they land, we'll put 3 men up for 56 days. They'll come down, and 30 days later, another 3 will go for 56 days. So a year of 73, calendar year, will certainly be a busy one from the standpoint of manned spaceflight.
December 10th, 1972. America and Challenger went into orbit around the moon.
Houston, this is America. You can breathe easier. America has arrived on station for the challenge ahead.
The next day, December 11th, Cernan and Schmidt entered the lunar module and undocked.
You look just as pretty in Earth light as you do in sunlight. Roger, America. Have a good burn. You're loud and clear.
With the command module in the distance, they passed over their landing place, a valley in an area of the moon called Taurus Littrow. Here they hoped to find the youngest material yet sampled and direct evidence of lunar volcanoes.
You're looking real good, Gene. Right down the line.
Oh, man, we're level with the top of the massif now. Okay, stand by for pitch over. Oh, are we coming in? There it is, proceeded. And there it is, Houston, there's Camelot. Wide on target, I see it. We got them all. 42 degrees, 37 degrees, through 5,500. 53 degrees. Okay, I've got Barhay, I've got Poppy, I've got the triangle. That's 2,500 feet, 52 degrees. H-dot is good at 2,000. H-dot is good. Fuel is good. Going down at 10, cut the H-dot. The fuel's good. 110 feet, stand by for some dust. Little forward, G.
Bend her forward a little. 90 feet. Little forward velocity. 80 feet. Going down at 3. Getting a little dust. Going down about 2. Very little dust. Very little dust. Stand by for touchdown. Stand by. 25 feet. Down at 2. Feels good. 20 feet. Going down at 2. 10 feet. 10 feet. Contact. Stop, push. Engine stop. Okay, Houston, the Challenger has landed.
Roger, Challenger, that's super.
Houston, you can tell America that Challenger is a Taurus Littrow.
December 11th. Cernan, then Schmidt, left the lunar module to begin their first EVA.
As I step off at the surface at Taurus Littrow, we'd like to dedicate the first steps of Apollo 17 to all those who made it possible.
Their first job was to unload equipment, including their rover, the electric car in which they would drive to the exploration sites.
That's beautiful. This has got to be one of the most proud moments of my life, I guarantee you.
We thank you very much.
As Cernan drove the equipment-laden rover, Schmidt carried the scientific experiments package called ALSEP.
Hey, do you need me, Gene? Nope. I'm going to go deploy an ALSEP. Have at it.
In Houston, scientists in the science support room watched, correlating and directing their movements.
Okay, Bob, I've got my tools of the trade right here.
As Schmidt set up the various experiments, Cernan drilled a series of holes, both to collect core samples and to implant experimental probes.
Oh, we're out in the ejector blanket of Camelot for sure now.
Yeah.
Man, it didn't feel like this stuff was that hard. No, I'll get it. I knew there was something I needed to do. Get the jack in over here, other side. Let me put some weight here.
Not going anywhere.
Oh, he's going slowly, Bill. Very slowly.
I'm gonna get this thing out now that I got it.
Boys, you know, that's what you call getting down into your work.
.29.5.
Yeah, it's 29.5 minutes from now, but remember, they left this side a little bit late.
There it is. Okay.
Jim, you better make it clear to Parker that we got to pull out.
On the moon and on the Earth, they were fighting time now. There are just so many hours of oxygen and water in the backpacks. So many hours of life in the vacuum of the moon.
We're up in this area.
There you go. Watch that cable. Cable.
Oh!
Cable.
Watch the cable. Cable number 1. You know, they're all fixed, Lee. They'll break the whole world before they'll break the cable this time.
With the ALSEP functioning, they left the site for a shortened sampling traverse.
Well, many parts of the ALSEP are functioning very well. The heat flow experiment is working excellently. It's transmitting back temperature data. The cooling down is still cooling down from the drilling process, and in a few hours they should be starting to get true heat flow information.
Let's see if I can't crack the corner and get that contact. See if I can't get her.
Look at the boulders out there. Jesus.
It was time to head back to the Challenger, activate experiments, and get back inside.
Man. I was strolling on the moon one day in a merry, merry month of December. No, May. May's the month. May, that's right. May is the year of the month.
As the astronauts rested, engineers in 2 nations were working out technical problems of the Apollo Soyuz test program, the first joint Russian and American space mission.
Well, the prime purpose of the Apollo-Soyuz joint mission is to prove out a compatible docking system and demonstrate that we have compatible operational procedures that will let two different countries dock in space. I think more than that, it has certainly a symbolic meaning of these two large powers learning to work together in space, which I believe are the new seas of mankind, the new frontiers, and work out solutions to problems wherein, although we're very competitive, we can still be cooperative and assist each other. And I think that this Apollo-Soyuz program stands for just that.
Oh, what a nice day. Oh, funny, there's not a cloud in the sky, except in the Earth. Think that'll stop the dust, that way?
They would have one task before they got to work exploring. The previous day, they had broken a rear fender of the rover. The dust thrown up was causing trouble. Apollo 16 commander John Young had worked that night in a pressure suit on a way to fix the fender.
Oh, okay.
On the moon, the astronauts put it together. The fender section formed from a lunar map, molded with tape, then held in place with clamps from the Lunar Module Telescope. It was a repair that would last the remainder of the mission. Then Schmidt moved out to place one of several explosive packages which would be detonated after they left the moon, mapping the lunar subsurface, much as earthly geologists explore for oil. Cernan would pick him up in the rover for the drive to the first site on this traverse, Station 2.
They're somewhere along this rim where they can see.
But they're dropping, Bill, so they must be coming across that thing.
We're right where we wanted to be for Station 2, and it looks like a great place. Big blocks. It looks like quite a bit of variety from here. Different colors, anyway. Pretty hard, isn't it? That boulder's going to roll. Man, that is hard. Just don't stub your toe.
The foreground features are somewhat different, simply because they were farther up onto the hill, I think. But otherwise, that's remarkable.
Pottery, it's obviously very cohesive because the bottom of the core is not smooth. It's very jaggedy and fragmental-like.
Gene's finished with the core tube, then we should be able to go.
If we get that pan.
No, dadgummit.
Jack Schmidt having a few problems.
Come on.
They would sample several locations on this EVA, but none would cause more excitement than the find at the crater called Shorty.
Oh, hey! There is orange soil. Well, don't move it till I see it. It's all over. Orange! Don't move it till I see it. I've stirred it up with my feet. Hey, it is! I can see it from here. It's orange.
That's it. That's the volcanic vent.
Somebody unplugged silver.
Fantastic, sports fans. It's trench time. Jack, that is really orange.
I think it's the most exciting we've come across since the beginning of the Apollo program. I believe that it's going to be the most rewarding of all the finds on Apollo.
Light gray material on either side. Oh, man, that's incredible. Okay, Gene, we're going to have to... That's incredible. You need to get a down-sun color.
There isn't enough time, Tony, to do it, no matter which way you want to do it. We need more time. We may have to slip 5 in a little bit.
He's getting about 3 centimeters of wax.
They got to leave at a certain time regardless of what we got.
Willing to give up all the light mantle stuff.
They had to leave Shorty Crater and its orange soil and push on. Time, the enemy of the lunar investigator on the moon and on Earth.
I can't believe we sampled the whole... I can't believe we sampled the whole thing right on.
The precious minutes had run out. Return to the rover, drive back to the Challenger, close out EVA-2.
we'd like you to leave immediately. Okay. My golly, this time goes fast.
As the last Apollo crew worked on the moon, the engineers on Earth prepared for tomorrow's day in space.
I have a model here of the space shuttle. As you see, it resembles a double-wing airplane on top of a propulsion system. The system is going to be designed so all of the costly parts are reusable. Now that we're beginning to understand space, we're beginning to understand the potential, the economic potential, the need is to bring larger arrays of instrumentation up in space. The need to provide man with a real capability to work up in space.
Okay, Bob, I'm on the pad, and it's about 4:30 a Wednesday afternoon as I step out onto the plains of Torres Littoral. Beautiful valley.
December 13th. Yesterday, they had explored the south end of the valley. Today, they would go north.
Yeah, well, let's ask for an extension. Hey, Jip, this is the last time for you to really go to bat for us, Jip. We know you'll do it for us.
10-minute extension for that L7. Yep.
Holy smoly! Why are we on a slope? You okay?
Man, that's rough country in there, isn't it?
Well, you're looking across Henry.
Yeah.
And let me see what it is.
Apollo science will continue, and I'm sure much of the mysteries will continue to come out for many years to come.
But of this I'm sure. Man has learned that space is his to explore. And man will return to space to explore, to the moon and beyond.
I'm firmly convinced that it's changed the whole basis of philosophy, including religion. I don't think that we've begun to see what the era of spaceflight really is. We've got a long way to go, and I hope I'm living when we leave this solar system on a venture to find another planet Earth.
You know, Jack, when we finish with station 8, we will have covered this whole valley from corner to corner. That was the idea.
Once more, it was time. Gene Cernan and Jack Schmitt returned to the rover to drive back to Challenger. But before they left the surface of the moon, there would be a brief ceremony.
It's a rock composed of many fragments of many sizes and many shapes. When we return this rock, or some of the others like it, to Houston, we'd like to share a piece of this rock with so many of the countries throughout the world. We hope that this will be a symbol of what our feelings are, what the feelings of the Apollo program are, and a symbol of mankind that we can live in peace and harmony in the future.
And a final word from the last man on the moon.
I'd like to just let what I believe history will record, that America's challenge of today has forged man's destiny of tomorrow.
While Cernan and Schmitt closed out the last moonwalk and prepared for tomorrow's liftoff, Ron Evans worked on in orbit. Photograph, observe, describe. Keep operating the cameras and experiments in the Science Experiments Bay. In orbit, as on the surface, the seconds are precious.
Possibility at this stage.
How is the experiment working now?
Working extremely well. We're looking for subsurface geologic structure in the broad sense, layering, for example.
This is the infrared scanning radiometer.
What does that do?
The radiometer measures the temperature of the moon and makes an accurate map of the temperature beneath the spacecraft. It is working with tremendous success.
One other thing, how is the experiment working mechanically as far as the man and the machine?
The experiment itself, the hardware is working perfectly, precisely the way it was supposed to work. Everything has functioned properly. An important part of the experiment is it requires the man to operate it.
99, proceeded, 3, 2, 1, ignition. Right away, Houston. Vector good. Ag thought. Good over. Roger, you have good thrust. Okay, 30 seconds. 308 your number. Stay coming through 1,500 feet, and H-dot looks good.
On the descent stage of Challenger, forever on the moon, they left a plaque reading, "Here man completed his first explorations of the moon, December 1972 AD. May the spirit of peace in which we came be reflected in the lives of all mankind." One revolution later, Cernan and Schmidt caught up with Evans and prepared for docking.
Good to see you. Good to have you all back up here. It's been a good trip. Man, that Challenger's a beautiful vehicle. You betcha.
December 16th. Burn out of lunar orbit and head home to Earth.
Houston, America has found some fair winds and following seas, and we're on our way home. Hey, this is great. Talk about being a spaceman. This is it.
December 17th. 170,000 miles from Earth. Ron Evans left the command module.
Hello, Mom.
We see you, Ron. You're looking great.
Okay. Hey, John. How you doing? Hi, Jamie.
Evans was retrieving film canisters from the two cameras and the lunar sounding radar. Data vital to the scientists on Earth.
And the lessons in.
Before he got back inside, Evans took a last look at the crescent Earth. In 2 more days, they would be home. December 19th. They rode inside a 5,000-degree fireball through the atmosphere of Earth. Stowed in the spacecraft, almost 250 pounds of the moon.
This closes a golden chapter in the age of space exploration. In a way, it brings a close to what has been a very romantic era in space exploration. But, and I want to make this very strong, the book is still being written.
The moon, a lonely world in the absence of man. But here we have left our mark, a signature attesting a legacy to future generations. We stood on the shoulders of giants and touched the moon.
What about this, what you told me before about the ranging? Do you still have some doubts about that, or is everything resolved now?
We're getting good ranging data now, Yuri.
Сейчас мы получаем хорошие данные по измерению дальности.
9/10 of a mile and have him wired.
Super, Tom.
Houston, flight, Zug Москва. Корабль «Союз» готов к стыковке.
Sure, the flight director and the other people here in the control center are happy to know that. I'd like you to know that Apollo is go for dock also.
Спасибо, Юрий Степанович, очень рада это слышать. Я уверен, что все остальные наши управленцы и руководитель полета будут тоже очень рады это слышать. Что касается Аполлона, Аполлон тоже готов к стыковке.
And if you'll excuse me just for a minute, I'll pass that word on now.
Вы меня сейчас извините, я передам ваше разрешение на стыковку.
You can see his antennas from out here, Dick.
Roger. Apollo, Houston, I got two messages for you. Moscow is go for docking. Houston is go for docking. It's up to you guys. Have fun.
All righty, sounds good. Palovina Mila Alexei.
Mid-July 1975. An American Apollo spacecraft and a Soviet Soyuz spacecraft prepare to join in Earth orbit, 140 miles above the Atlantic near Portugal. During their two-day joint flight, astronauts and cosmonauts transferred between spacecraft. They conducted space experiments, and they tested a compatible rendezvous and docking system, evaluating its potential as the universal standard on future spacecraft for docking and rescue. The mission climaxed more than 3 years of planning and preparation, a time during which differences in language, in technology, in political creed were set aside in favor of the common goal. This was the mission that opened the door to international manned spaceflight, the mission that set the course for joint flights of the future. This was the mission of Apollo Soyuz. In the pre-dawn calm of July 15th, the methodical countdown of Apollo moved with customary precision toward a mid-afternoon launch. Of lesser note was the fact that this would be the last flight of Apollo Saturn. And as the countdown narrowed, chances are that more than one member of the launch team reflected on other proud days of Apollo, like its 9 flights to the moon, 6 of which resulted in landing men there. Its 3 flights to Skylab, transporting crews to the orbiting space station. And now, in 9 days, the entire Apollo program would pass into history. Apollo would make way for a 2-way reusable vehicle, the Space Shuttle, scheduled for its orbital flight debut in 1979. But today, it is Apollo Soyuz. And as dawn approaches the Florida coast, a similar drama is nearing climax, half a world away. The scene, Baikonur Launch Complex in Kazakhstan, central USSR. The Soyuz spacecraft, its crew approaching the end of pre-launch checks, is about to signal the start of this historic mission. At Mission Control Moscow, flight controllers monitor Soyuz as it gathers momentum en route to orbital altitude. Less than 9 minutes after launch, Soyuz, powered by triple booster stages, is inserted into its assigned orbit.
This is Apollo Saturn Launch Control. The countdown has proceeded smoothly this morning, and the flight crew here at the Kennedy Space Center were alerted about 10:30. They're right now in the suit room at the Manned Spacecraft Operations Building, donning their spacesuits, and they're scheduled to leave the suit room about 12:37 for the trip out to Pad B. The weatherman continues to be cooperative.
A near-perfect day for the launch. Made to order for the thousands lining the roadsides and beaches to witness this Apollo Saturn finale.
Starts at 3.1 seconds in the countdown. We'll hold down till thrust builds up.
11.
Engine
10,
ready light on.
9,
10, 9,
8,
8, 7, 6, 5, 4, 3, 2. Engine sequence start. 1, 0. Launch commit. We have a liftoff. All engines building up thrust. Moving out. Clear the tower.
Roger, power clear. Roger, Tom, you got good thrust on all engines. You're right on the money. 30 seconds, we're on the way. Stand by for mode 1 Bravo. Mark, 1 Bravo. 1 Bravo, 2 Gs. Roger. And cabin pressure's coming down. Roger. Apollo Houston, you're go for station. Roger, go for station. Okay, and that light is out on the 4B. We got acceleration. Roger.
Apollo is placed in orbit.
5, 6, 7, go. Now.
And before the flight is 3 hours old, the docking module is smoothly extracted from the second stage booster, left trailing behind. During the next 40 hours, Apollo, through a series of maneuvers, will slowly close the orbital gap with Soyuz. The two crews will meet again, not as members of this or that nationality, but as friends who for 3 years shared their separate cultures and customs, and a part of themselves. In preparing for their mission, Soviet and American crews spent a good deal of time together. In formal mission training, in learning about the other man's culture, in getting to know the man himself.
In the United States, I want to visit Hollywood.
Alexei Leonov, Soyuz commander.
Because I want to be a movie star.
Colonel in the Soviet Air Force.
No, I don't want. Tom Stafford want.
In 1965, on the flight of Voskhod 2, he became the first man to walk in space.
Right now, we're optimistic we'll meet the launch schedule. The hardware's in good shape. As far as astronaut and cosmonaut training, we're in good shape. When you put the whole thing together,
The Apollo commander, Air Force General Thomas Stafford.
Concern about it.
Before this mission, he had flown 3 times in space. He was commander of Apollo 10, the mission that orbited the moon and qualified the lunar module for subsequent lunar landings. A civilian and a veteran of the U.S. space program, Donald K. Deke Slayton. One of the original 7 astronauts, he was scheduled to pilot the 4th manned Mercury flight. A slight heart irregularity interrupted his flight career. He was returned to full flight status in 1972 and assigned to Apollo Soyuz as docking module pilot. Another civilian crew member, Valery Kubasov, age 40, the Soyuz flight engineer. On Soyuz 6, he successfully performed the first welding experiments in the zero gravity of space. Rounding out the American crew, Vance Brand, civilian, aeronautical engineer, former test pilot. He's been a backup crewman on previous flights, but this was his first trip into space. He is the command module pilot. As this was a time of mission preparation, it also brought together engineering and technical specialists from both sides. Heading up the teams were Dr. Glyn Lunny, the American project director, and his Soviet counterpart, Professor Konstantin Bushuyev. Under the direction of these two, an atmosphere of cordiality and mutual respect developed that pervaded the many months of meetings and negotiations. Joint groups were assigned to 5 general areas: communications and tracking, life support and crew transfer, mission planning, control and guidance, and mechanical design. This latter category included the building of the first universal docking system. The system's development, its ultimate testing in space, constituted a specific goal of the Soviet-American Space Agreement signed in Moscow in 1972 by the chief executives of both nations. Although each nation designed and built its own half of the docking system, the interface, that is, the physical mating of the two, was a single design. Considering the language barrier, the differing technologies, 2 diverse political systems, the development program moved with relative ease. There were differences, to be sure, but none that was above negotiation and compromise. Perhaps Professor Bushuyev put those differences in the proper light. He said, "In our joint work, there has been only one contradiction. Dr. Lunny drinks black coffee, and I drink mine with cream."
Okay, copy.
This is Apollo Control. Apparently the TPI maneuver was indeed successful. Tom Stafford reported from Apollo that he was station keeping with Soyuz. Both control centers, Moscow and Houston, have given a go for docking.
Soyuz, Apollo, как слышать? I need you 5x5.
Hello, Houston.
Can you see the Soyuz?
Okay, he's sitting behind the docking module. Uh-huh. Here he comes, just above the docking module. Looks real pretty.
Soyuz docking system is ready.
Good show. Let's stay there. Looking fine.
I'm approaching Soyuz.
Tom, please don't forget about your engines.
Less than 5 meters distance.
3 meters.
3 meters.
13 meters.
1 meter. Contact. Capture. We also have capture.
Roger, Tom. We'll pass it on.
Soyuz and Apollo are shaking hands now.
Houston, Apollo.
Go ahead, Tom.
Говорит Professor Bushuyev, tell Professor Bushuyev it was a soft docking.
Around the world, millions watch and listen as the 2 spacecraft become one. Now they wait for the next dramatic event, the meeting of Soviet and American crews.
All right, on a show. Открываю loop 3. Okay, the camera. Ah! Здравствуйте. Got it? It'll stay open.
Go ahead. Go ahead, Tom. Lexi. Just a moment. If you turn on the camera, hit the remote. Okay. Here. Glad to see you. Here. Очень рад. Это Россия, Советский Союз, Соединенных Штатов.
In the first crew transfer, astronauts Stafford and Slayton are hosted in Soyuz by cosmonauts Leonov and Kubasov. Vance Brand remains behind to monitor Apollo systems.
In the name of the Soviet people and from myself personally, I am
to mark the occasion, leaders of both the USSR and the United States relay their congratulations.
Of the Soviet spacecraft, new possibilities are opening up for fruitful development of scientific cooperation between countries and the peoples in the interest of peace and progress of all humanity. I wish you successful completion of the planned program and a safe return to Earth. Leonid Brezhnev.
The astronauts are on the line, sir.
Gentlemen, let me call to express my very great admiration for your hard work, your total dedication in preparing for this first joint flight. It's taken us many years to open this door to useful cooperation in space between our two countries. And I'm confident that the day is not far off when space missions made possible by this first joint effort will be more or less commonplace. And may I say, in signing off, here's to a soft landing.
Thank you very much. Thank you, Mr. President.
Among ceremonies scheduled for this first day of joint flight are the exchanges of national flags by the spacecraft commanders. Later, they sign certificates of docking with the Paris-based Fédération Aéronautique Internationale, the organization that validates all aviation and spaceflight records. Finally, they sit down to dinner in space, Russian style.
Right now, I've just finished some strawberries reconstituted. I'm deep eating some too. We're getting ready to eat some borscht, as you can see here.
Following breakfast in their separate spacecraft, the crews begin the second day's slate of activities, which includes working on the joint experiments. An electric furnace is aboard for high-temperature testing of metal alloys and crystal material samples. One of these samples is a joint experiment. Investigators believe that uniform mixtures of metals and perfect lattice structures can be consistently achieved in materials in the non-gravity of space. In the day's first transfer, Vance Brand visits Valery Kubasov in Soyuz, and Colonel Leonov is hosted by astronauts Stafford and Slayton in Apollo.
Hello, American people. The first Soviet American TV.
Activities begin with a tour of both spacecraft. Kubasov shows Soyuz to the American audience.
Soyuz. It's a computer.
Tom Stafford explains Apollo to Soviet viewers.
Очень важно. It's been a most rewarding 2 days here in space, working with the Apollo-Soyuz project.
Soon after the third transfer, the spacemen field questions from the Soviet and American
Soviet
press.
Union and the rest of the world has seen is the results of the determination, the cooperation, and the efforts by the governments of the two countries, by the managers, engineers, and all the workers involved. It's been a very rewarding experience.
Roger, it's Moscow's turn to ask the questions that have been proposed by the press there.
Thank you, Bo. Alexei Leonov.
Насколько считаете вы
комфортабельным корабль «Аполлон». И как вам нравится американская пища?
Consider the Apollo spacecraft to be, and how do you like the American food?
Я сегодня 6 часов пробыл на космическом корабле «Аполло», это в космосе. Но as old philosopher says, the best part of a good dinner is not what you eat, but with whom you eat. Today...
North of New England, as the workday ends, Tom Stafford presents Alexei Leonov's spruce tree seeds to be planted in Russian soil, a gift from the American people to the people of the Soviet Union to provide a living memorial to the flight. The spacecraft commanders also joined the two halves of an Apollo-Soyuz medal. One half launched with Soyuz and the other half with Apollo to symbolize the link-up in orbit. When time comes to retire to their own craft, it's das vidanya and goodbye. The joint experiments would resume the following day, but only by voice. The next face-to-face meeting would be in Moscow in September.
This is Apollo Control. At acquisition here, we should have confirmation of undocking and a real-time television picture of Soyuz from Apollo as it backs away in preparation for the solar eclipse experiment.
Solar eclipse occurs briefly and infrequently on Earth, giving scientists too short a time for adequate study. But with two-manned spacecraft and proper maneuvering, a solar eclipse can be simulated. Thus, with Apollo blotting out the solar disk, the Soyuz crew trained their cameras on the solar corona, recording pictures for later study. They dock again, providing yet another test of the compatible docking mechanism.
Apollo, Houston, it was a beautiful docking. We had a good picture. We can see Italy coming up in the Mediterranean right now. Apollo, Houston through Atson, we're hearing your calls.
Roger, we've docked. Everything was on time, though.
After some 3 hours, the two spacecraft separate for the last time, and Apollo maneuvers into position for the final joint experiment, ultraviolet absorption, the measurement of oxygen and nitrogen particles in the upper atmosphere. Apollo directs light beams of special wavelengths to a reflector mounted on Soyuz. The beams bounce back to Apollo and are there analyzed by a spectrometer. It is the first such measurement by this method. The results have given investigators a clearer knowledge of outer atmospheric makeup, including the quantities of ozone in the upper atmosphere. Termination of the experiment signals the end of the joint phase of the mission, and the separation between spacecraft grows more distant with each successive orbit. Apollo will fly solo for 4 more days, but the crew of Soyuz makes ready for return to Earth.
Good morning again. Jim Hartz and Alan Shepard from the Mission Control Center in Houston, Texas. Live this morning, the Soviet spacecraft is about to land in the Soviet Union.
The Soyuz recovery, a focal point of media coverage, is typical of worldwide interest in the mission. Not since the first landing on the moon 6 years earlier has the Houston News Center seen this much press activity. Beneath its single striped parachute, Soyuz settles to Earth in Soviet Central Asia. Retro rockets cushion the impact.
The parachute.
3 memorable years have ended. Alexei Leonov and Valery Kubasov have secured yet another place in the history of spaceflight. Apollo continues in orbit, carrying out the remainder of the 27 experiments in space sciences, life sciences, and applications. Among the less notable passengers aboard are numbers of killifish. Sealed in seawater, they are in key stages of maturity. Scientists want to pursue an earlier investigation in which fish taken into orbit on Skylab had orientation difficulties in zero gravity, while those that were hatched in orbit adapted quite well. On return to Earth, the specimens will be compared to similar stages of Earth-raised fish. Through highly refined instruments, they look out in our galaxy and beyond. A new source of radiation is found, the extreme ultraviolet, which many scientists thought would remain forever invisible. Others felt it didn't exist at all. The discovery ranks high in importance and may open a new branch of astronomy for studying the universe. They attempt to locate the sources of soft X-rays. They probe the temperature and abundance of the interstellar medium. They test ways of long-term monitoring of aerosol particles in the atmosphere, which may have profound effects on our weather and environment. They look back on Earth, on those features that will yield the greatest results: geological features, the oceans, the deserts, pollution patterns, weather formations, all the phenomena that comes under the general heading of Earth resources. As the mission comes down to the wire, the docking module is jettisoned, and it too becomes part of an experiment. With the two instrumented spacecraft close together in the same orbit, it is possible to measure their relative movements caused by variations in Earth's gravity. The technique provides a means of accurately mapping the Earth's mass structure on a global basis.
Final.
Go.
Gato.
Go.
Retro.
Go, flight.
GNC.
Go flight.
Apollo Control, 99 hours, 29 minutes, phase elapsed time. Flight Director Frank Littleton
Go.
pulsing his flight controllers. ECOM reports everything looks fine.
Go for the burn.
Okay, Crip, everything's up. Great shape up here. The only thing we're concerned about is that you've got all your splashdown parties coordinated, over.
Well, I've been working on that.
Okay, sounds good.
In Pacific waters west of Hawaii, Apollo reaches the end of its journey and the end of an era.
Waving to the crowd, assembled here on the hangar deck of the USS New Orleans. Captain Logan giving them a few more words of briefing about the ceremony, which will take place in just a few moments. Now they walk down a red carpet toward the... Thank you. I know it's customary to say that it's great to be back. We're happy to be here.
We didn't know it at the time, but during re-entry, gas from the attitude thrusters had entered the command module, creating a hazard. Quick action by the crew in recognizing and correcting the problem avoided a potentially tragic incident. They were later hospitalized in Hawaii for observation and treatment. The symptom cleared in a few days, and the crew was released. The spirit and the letter of the 1972 joint agreement had been dramatically fulfilled. Hopefully it represents a prelude to the future, to a time when all mankind will share the work and the dividends of space. The space shuttle is a major step in that direction. The shuttle will transport into orbit a European development called Skylab. With 10 countries of Europe sharing construction and cost, men and women of many nationalities will be able to apply their creative talents aboard Skylab for the benefit of the world community. But for Skylab, for Shuttle, for all the cooperative space efforts to come, the groundwork has been laid by Apollo Soyuz, the model for the future.